Next up, we have the quantitative side of things. So we're going to take a look at figuring out formula weights. We already did this for average atomic weights, average atomic masses. So we're going to look at what happens when you have an entire compound. So what we do is we would analyze each element individually and figure out their masses. And again, this should be something that as an AP Chem student you've done before. So if we look at the formula here, we would see that in one formula unit, we would have 2 atoms of nitrogen. We would have 8 atoms of hydrogen, 1 atom of carbon, and 3 atoms of oxygen. To figure out the masses of these, we're going to go over to the periodic table. So we have nitrogen, carbon, hydrogen, and oxygen. So we'll use all of those masses there in our calculation. I'm going to round each of these to 1 decimal place. So nitrogen would be 2 times 14 AMUs, 14.0. Hydrogen would be 8 times 1.0. Carbon, 1 times 12.0. And oxygen, 3 times 16.0. 48. 48.0 AMUs. And so the combined formula mass for ammonium carbonate will be 96 AMUs. Avogadro's number. So we start out looking at individual atoms, and we long knew that the relative mass of carbon was 12.01 atomic mass units. Starting out with hydrogen as being the fundamental unit, and everything is based on hydrogen. Now it's actually based on the isotope of carbon that has 6 protons and 6 neutrons. If I took 10 atoms of carbon, I would have a mass of 120.1 AMUs. Right. Very, very small amount, not something we could measure on a balance. If I took 1,000, I would have 12,010 AMUs of carbon. Still way too small for us to measure. Well, eventually we would get up to enough atoms of carbon where the mass could be measured, and if we got to a point where it was 12.01 grams of carbon, so not atomic mass units, but grams, that number seemed to be kind of a significant number. And that is 6.022 times 10 to the 23rd. And that is a term that's given to, of course, 1 mole. So again, similar to a baker's dozen, when we start working with amounts of our elements and compounds, we're going to deal mostly with moles of things, which are equivalent to 6.022 times 10 to the 23rd of those. So that way our masses are going to be in the ballpark of what we can measure with the instruments in the lab. So what is the mass of a mole of sodium carbonate? Well, if we go back for just sodium carbonate. So again, we would do the same kind of thing we just did. Sodium carbonate. Excuse me. So here would be the formula for sodium carbonate. We would have 2 sodiums. We would have 1 carbon, 3 oxygens. We would add these together. Similar to what we did for the ammonium carbonate, and we would get a formula weight of 106 atomic mass units. Now that would be for a single formula unit of this. So 2 atoms of sodium, 1 atom of carbon, 3 atoms of oxygen. If we go to a whole mole, so 1 mole of sodium carbonate would have a mass of 106 grams. Okay, and this is our molar mass that we'll use quite frequently in our calculations. As a matter of fact, the next problem will ask us to do this. So here we want to calculate the mass in grams of sodium ions and 10 grams of sodium carbonate. So if I start with my 10.0 grams of sodium carbonate, put that over 1, and recall from our last problem that there are 106 grams of sodium carbonate per 1 mole of sodium carbonate. In 1 mole of sodium carbonate, you would have 2 moles of sodium ions. And each mole of sodium ions would have a mass of 23.0 grams. Okay, so you can see how we would use the conversions to get to the number of grams of sodium from the number of grams of sodium carbonate that we started with. The other way we can use molar amounts of a compound is to determine the percent composition of a substance. So for instance, what is the percent composition of each element in water? Well, water is H2O. If we assume 1.0 moles of water, we would have 2 moles of hydrogen, 1 mole of oxygen. The 2 moles of hydrogen would have a mass of 1.0 grams. Sorry, 2.0 grams. The 1 mole of oxygen would have a mass of 16.0 grams. And then figuring out the percent hydrogen would be the mass of the hydrogen part divided by the mass of all of the water times 100%. So the mass of just the hydrogen part would be 2.0 grams. The entire mass of the sample of water would be the 16 plus 2, or 18.0 grams, times 100%, which gives us 11.1% hydrogen. Likewise, you could do the same steps to get the percentage of oxygen within the compound water. As part of your homework, figure out number 2 here, which is which one of the following has the most atoms. You should be able to do this without your calculator, but using the periodic table. All right, so go through this carefully and be ready to explain your answer when you come to class.